Here's the Chemistry 1 video covering significant figures. So in chemistry, we don't really deal with numbers per se. We have a joke that we say that numbers are for math and math is hard. They don't like us saying that, but whatever. No, in chemistry, we deal with quantities, and quantities are different than just numbers because a quantity is something that you measure, or it can be measured, and contain both the number as well as a unit. Essentially, chemistry and science in general is math with a purpose. Math says 2 plus 2 is 4. Science explains why are we adding 2 plus 2 to equal 4 in the first place. When we're dealing with measurements, only some numbers matter. We call those numbers significant figures. Significant figures are a really important portion of chemistry and science in general because of a couple things that we'll talk about at the end of this video. But when we are talking about significant figures, they include all of the known values that you are 100% sure of, as well as one estimated number, one unknown number. And we'll give some examples of known versus unknown numbers here in just a second. So here we have some rulers, 3 rulers, A, B, C, with different measurements on it. So a measured quantity, we're going to get because we can measure it, it's a quantity and not just a number. It's going to be a number with a unit. So if we're looking at ruler A, we have a mark at 0 centimeters and we have a mark at 10 centimeters. We can't be 100% sure where 1, 2, 3, 4 centimeters are when we're using ruler A. But maybe that's all you have. That's the resource that you have, so you have to use it. You can't know any numbers, but you're allowed to make one estimated guess. It looks like it may be somewhere between 3 and 4. So we're just going to guess 3. Using ruler A, the best guess that we could get is that piece of wood or whatever we're measuring is 3 centimeters long. Maybe someone comes along and says, oh, well, you have a really cruddy ruler. Here's a slightly better one. This one has marks every single centimeter. And you can see 0 centimeter, 1 centimeter, 2 centimeters, blah, 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 blah. With ruler B, you can now be 100% certain that you are at least 3 centimeters long. You know for a fact, 100%. You could argue until you're blue in the face, 100% confident that that thing is 3 centimeters long, which means you know that it is 3 centimeters. But the difference between A and B is with A, we weren't sure. We were already making a guess. You have to make a guess. With ruler B, we are knowing that it is at least 3 centimeters, but we still have to take a guess. Now, we don't have the little marks to prove exactly where it is, but it looks like it may be 0.2, 0.1, let's say 0.1. So our guess this time is going to be 3.1 centimeters. We went to what we knew for sure, 3, and then we went 1 unit further, 1 decimal further, 3.1. Now let's switch it up again. Instead of ruler B, we're going to use ruler C. Ruler C not only has the centimeter marks, but has millimeter marks. We can be a little bit more sure of our answer. We are still sure that it's past 3 centimeters. That's what the ruler says. But now because of those extra little tick marks, we can be sure that, oh, hey, that's at least 3.1. I can take that measurement, I can compare it to the ruler, and I can argue with anyone who wants to walk into my door, this thing is at least 3.1 centimeters long. I'm not guessing at that. I know it. The ruler says it is 3.1, but you always have to take a guess. So we're going to go 1 decimal further. I know that I have at least 3 centimeters. I know I have at least 3.1 centimeters. It looks like maybe it's between 0.1 and 0.2, so we're going to say 3.15 centimeters. So this is maybe about halfway. I'm not sure if it's about halfway. Maybe you want to come in and say that it's only about a quarter of the way between 0.1 and 0.2. That's okay. That's your guess. But you are allowed to estimate and have to estimate 1 digit. We guessed with our 3 in ruler A. We knew 3 there, and we guessed that 0.1. With ruler C, we knew 3, we knew 0.1, so we guessed that 0.5. It's a pretty safe assumption if we ever give you a problem like this where we say, hey, here's a number, circle what you know of and underline what you don't. The last digit you see will always be your estimated value, your unknown value, the value that you guessed at. So with that first example, 7.6, you are guessing at 0.6. Which means if you're guessing at 0.6, you had to know for sure that you had at least 7 centimeters. That's something like ruler B. You could know the 7, but you didn't quite know the 0.6 for sure. So you had to make a guess at it. Next one, 2.34. You are guessing at that 0.04 at the very, very end, which means you have to know the 2.3. You know because your ruler says this is at least 2.3, and you could prove it. You have the mark to prove the 2 centimeter. You have the mark to prove the 0.3 centimeter. That's something like ruler C. Last but not least, 15. Now, when you look at that, it's always going to be your last digit, which means we're going to guess at that, the 5 part of the 15, the ones place, which means you have to know for a fact that your thing is at least 10. Well, if you look back at your A ruler, you have a mark at 0, you have a mark at 10. If you had a long enough thing that you were measuring, you could prove that this thing is at least 10 centimeters. But if it's somewhere between 10 and 20, and you're not really sure where it falls between 10 and 20, maybe 15 is your best guess. You know it's at least 10, but maybe you're guessing it's about halfway. Well, that's where the ones place would come in. This portion isn't in your notes, but we will be using balances a lot in the lab, and we'll be doing a lot of measurements. Balances are nice. If you were using a balance to weigh a mass of an object or a chemical or a compound, whatever, balances have that last estimated value built in. In other words, whenever you're using a balance to measure a mass, you are going to copy whatever number is on the screen. You're not going to add an extra number on the end of it. You're just going to copy exactly what's on the screen. The reason that you can copy that, and if you've ever used a balance before, sometimes it does that jump up and down. Maybe it's 1.17, then it turns into 1.18, and then down to 1.16. That's because it's constantly trying to estimate that last digit. Just copy down the number, one of the numbers is on that screen, and you'll be good to go. Okay. So, talking about significant figures, why are significant figures important? Why do we care? Well, I have a number there, 2 grams versus 2.00000 grams. Those are effectively the same number, but the difference is having those more significant figures means you are more confident in your answer. In other words, with that 2 grams, you're estimating it's about 2. But if it's 2.00000, the only number you're guessing at is that last 0. You're confident about everything else there. You are sure that it is 2.000, and you're guessing at that last 0, which means more significant figures means more precision. And we'll talk about the difference between accuracy and precision here in just a second, but know that more significant figures means more precision. Now the question is it more accurate? No. I mean, we talked literally when we opened this portion of the slide, those are the same numbers. 2 and 2.00000 is the exact same value. The number is effectively the same. The difference is we're more confident in that second one. So is it more accurate? No. And we'll talk about how we determine accuracy here in just a second. Last throwback to the rulers. You had ruler A, ruler B, ruler C. The ruler that was the most precise was C. It was the ruler that gave you the most confidence in the measurement of that length. So what is the difference between precision and accuracy? Accuracy is correctness. In other words, let's say I measure my mother, or your mother, whatever, to be 6'2" tall. How would I know if I measured that accurately? What would I need to know? Well, you'd need to know the true value. You would have to know whether or not your mom is actually 6'2" tall. If she is, then yeah, you did measure accurately, well done. But if you measure your mother to be 6'2" tall and your mom's actually only 4'4", no, you didn't know that. You didn't measure accurately. You have to know the true value in order to determine accuracy. Precision is repeatability. Can you get the same measurement over and over and over again? So let's say measure my mom to be 6'2", then you come back in like 5 minutes and you measure again. This time you get 3'7". Then you measure her again, and now you're 5'2". Those three measurements are nowhere near each other. You're not being precise. Precision means repeatability. If you were to be precise measuring my mother, or your mother, whatever, you would have to get 6'2" every single time. If you're able to get 6'2" over and over and over and over again, then and only then can you say that you're being precise. Here's a picture kind of to help you understand the difference between precision and accuracy. If we're going to look at the top left, this guy right here, accuracy is, are you dead on the target? Are you in the bullseye? Are you hitting the bullseye? That's accuracy. Well, with number 1, the top left, yeah, you're hitting the bullseye. You are being accurate. It is a separate thing to be precise. In order to figure out if you're precise, you have to ask yourself, okay, am I hitting the same spot? Am I repeating the results that I'm getting every time I take a shot? Well, with that top left one, not only are you hitting in the center, you're hitting the center over and over and over and over again, repeatedly. You're hitting around the same spot. So for that first one, we would say that you are both accurate and precise. Let's look one over to the top. So in the top right, again, 2 separate questions. First question is accuracy. Am I hitting the center of the target? No. You're not hitting the center of the target, so you're not accurate. It's that simple. Then you can go to the second question. Am I being precise? In other words, am I hitting the same spot over and over and over again? So when you look, hey, all of my shots are in about the same place, which means I'm being precise. I'm hitting over and over and over and over again in the same spot. I'm being precise, but I'm not hitting in the center of the target, so I'm not accurate. Now let's look at the bottom left. Okay. First question, am I being accurate? Am I hitting the center of the target? This one's a little confusing. And we'll never really give you one that looks quite like this, because when we talk about accuracy, we talk about all of your points averaged together. So this guy and this guy kind of count each other out. This guy and this guy kind of balance each other out. This guy and this guy kind of balance each other out. So we would actually say that that bottom left one is accurate. I know it's weird. I know it seems wrong because, oh, well, you're not hitting the center of the target. You're hitting the red portions. I know. We're never going to give you an example where you're only accurate. But then you can move to the second question. Am I being precise? That one is really, really, really obvious. Because look at that the bottom left target. Are you hitting the same spot over and over and over? No, you're all over the place. Some are to the left, some are to the right, some are above, some are below, some are right and center. They're all over the place. So that thing is not being precise. It is only being technically accurate. Again, if that's weird or confusing or you disagree, don't worry about it. We're never going to give you that bottom left example. Last but not least, the bottom right. First question, am I being accurate? Well, even if you kind of average all those shots together, you still only get to be about there. That's not accurate. That's not accurate at all. You're nowhere near the center of the target, so you're not accurate. Then you look at precision. Are you hitting the same place over and over and over again? Same idea as that bottom left. You're all over the place. Some are in the blue, some are in the red. You got one that's kind of in the yellow there in the center. So not only are you not accurate, you're not being precise. That's neither. Okay, so it's another visual representation to kind of help you with this idea of accuracy versus precision. Please, please, please know they are not the same thing. You need to have an understanding of accuracy. You need to have an understanding of precision. So let's jump back to significant figures for just a second. There are some rules to determine what significant figures are, which numbers count, and we're going to go through those rules here in just a second. The first rule is really simple. Anything that is not a zero, in other words, counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, those numbers always count for significant figures. They are 100% of the time. If it's not a zero, it does count as a significant figure. Zeros are where things tend to get a little bit trickier. There are 3 separate rules for significant zeros. In class, this is the practice problem that we give to help you determine, or to help you to try to find some guesses for what rules count. The highlighted zeros are the ones that are significant. If you want to take a little bit of time to see if you can maybe guess at why the highlighted ones are significant while the other ones that aren't highlighted aren't, you can. But here are the real rules for zeros and significant figures. Like I said earlier, there are 3 rules. The first rule says that leading zeros are never significant. Now, when I say a leading zero, these zeros that I'm talking about are these zeros that come before the very first non-zero number. So I'll say that again. Leading zeros are any zeros, whether it's 1 or 2 or a million, that come before the first thing that is not a zero. So all of these guys right here that I just underlined, those are leading zeros. They never, ever, ever count for significant figure purposes. The second kind of zeros we call sandwiched or trapped zeros, and they are always significant. Now you can recognize a trapped zero or a sandwich zero because they are any number of zeros that are sandwiched or stuck between 2 things that are not zero. So I have a couple of zeros between the 1 and the 7. The 1 is a counting number, the 7 is a counting number. So any zeros stuck between two non-counting numbers, between 2 counting numbers are always significant. Those 2 would always be considered significant. Last but not least, and the most confusing of the 3 rules, trailing zeros only count, so they sometimes count, if there is a written decimal in your number. So using the above example there, if I were to have another couple zeros on the end, a trailing zero is any set of zeros that come after the last non-zero number. So 7 is the last non-zero. Anything that comes after that is considered a trailing zero, and they count if there is a decimal. So using this example, I have a decimal way up here. It doesn't matter where the decimal is. If you have a decimal, a trailing zero or trailing zeros count. Whether there's 1 or 1,000 of them, they count. So in this example here, those guys would count. But maybe here's another example. So maybe that's the number we give you, 700,100. Well, I have no leading zeros. There's no zeros before, so I don't have to worry about those. Here I have another 2 trapped zeros, so those guys definitely count. These last 2 are my trailing zeros. They only count if I have a decimal written. Well, as I've written this, I have no decimal. There's no decimal in that number. So therefore here, they would not count. That's why it's the most confusing rule, because sometimes they count and sometimes they don't. You just have to be careful. So here are all of the class practice problems that we have. We're going to do a few, and then, like normal, pause the video, try to work a few more of them out, and then all of the answers will pop up on the screen. So let's look at number 1, 0.02. You have to identify your zeros first. Before you go start counting, before you make any guesses, first just identify the kinds of zeros that you have. So 0.02. Both of these zeros are considered leading zeros. They are zeros that come before the first thing that isn't 0. And according to our rules, leading zeros never ever count. So we know those guys don't go for significant figures, which means in the number 0.02, there is a single significant number, significant digit, 2. It's the only one that counts. It's the only thing there that counts. So let's look at number 2, 0.020. Same idea. Let's identify our zeros. Well, I have 2 leading zeros that come before the first thing that isn't 0, and I have a single trailing 0, the zeros that come after the last thing that isn't 0. So I have 2 leadings and 1 trailing. Well, according to my rules, my leading zeros never count. So those 2 don't count into the total. Trailing zeros count if there is a decimal somewhere in the number. Well, in the number 0.020, there's a decimal, the point, which means in this particular case, that trailing 0 is going to count, which means I have 2 significant digits. Let's jump down a little bit to 5 and 6, because 5 and 6 are pretty interesting. It's the same number, effectively, right? 5,000. The difference between 5 and 6 is in number 5, there's no decimal at the end of that number. In number 6, there's a decimal at the end of that number. So let's look at number 5 first. Let's identify our zeros. Well, I have 3 zeros after the 5, which means they're all trailing zeros. They're all zeros that come after the last non-zero. So we know, according to our rules, rule 3, trailing zeros only count if there is a decimal present and written in that number. Well, in number 5, there's no decimal. There's an imaginary one at the end, but it's not written, so you can't look at it, which means for number 5, those 3 trailing zeros don't count. There is only one significant figure in that number. It's the 5. But let's look at number 6. Same idea. 3 zeros come after the 5. They're all trailing. The rule says trailing zeros only count if there is a decimal written on that number. Well, hey, look, there's a decimal in that number. At the very, very end, it is written, and you can see it. That tells me that in number 6's case, there are 4 significant digits. What you're really saying is that for number 6, you are more confident in those zeros. Those zeros aren't really guesses except for maybe the last one. Whereas with number 5, all of those zeros are basically guesses. Now let's jump across the way for a second and let's look at 14, just because it's got kind of another mix of zeros in there. So 10,810, number 14. So before we can sit there and start counting, let's identify our zeros. I have a single sandwich 0 stuck there between the 1 and the 8, and I have a single trailing 0 because it's the last set of zeros that come after the last non-zero number, come after the 1. So we know, according to our rules, sandwich zeros that stuck between the 1 and the 8, they always count. So you have to include that in your count of significant digits. But with trailing zeros, so now we approved this one, basically. We said that one's good right there. But with the last one, we have to check for a decimal. There's no decimal written. Actually, hang on. Yeah, just want to make sure there was no decimal underneath my writing. There is no decimal written in that number. So that last trailing 0 does not count. The sandwich one will always count, but because there's no decimal, the trailing 0 doesn't count. So for number 14, we'd say it would have 4 significant digits. Go ahead and take a second, pause the video, work through some more of these problems. You don't have to do every single problem, because it's a lot. I know there's 20 problems there. But take some time to go through and see if you can get the number of significant digits. And they'll pop up on the screen here in a few seconds. So here are all the completed answers. Hopefully yours more or less match what we have here. If you're still having trouble identifying your zeros, or you don't understand why sometimes a zero counts if it's trailing, but also others when it does count, or if you're having trouble identifying what zeros you have, please come see us. We're happy to sit there and write any number of problems to kind of help you work through. We will work through them with you to make sure that you understand how to identify number of significant figures. It's going to be really important in the long term. We will continue to check significant figures in basically every unit between now and the end of the year. So please make sure you have a good understanding of significant figures.